This is Mr. Anderson for Kellogg Community College, and we will be looking today at Section 6 of Chapter 6, Long Division of Polynomials. And the main purpose of doing this is to check to see if the item that we're dividing by can factor perfectly into the numerator, or factor into the problem we're dividing into. Because if you get a remainder of 0, then you have a perfect factor. So this is one of the very traditional and yet kind of long methods of solving for, or just trying to find if one thing is the factor of another. Like, for example, in this problem, we have the numerator of 25x cubed, negative 25x cubed, 20x squared, negative 3x plus 7. And we're checking to see, is negative 5 perfectly go into each of these? Now, another way to think of this is that since all of this is being divided by a monomial, we can put this monomial under each of these, and we can kind of treat that as something that it's dividing by each time. Now this is only because it's a monomial. We can't really do this for a binomial. So we can do some simplification top and bottom. So negative 25 divided by negative 5 is positive 5, and 3 minus 1 is 2. That's power simplification. 20 divided by negative 5 is negative 4, and 2 and 1 make 1. Here we have negative 3 divided by negative 5 does not simplify to a whole number, but we can make it 3/5, and there's no x's left over. And finally, for the last one, this just becomes negative 7/5 x, and the x is in the denominator because that's where it was in the beginning. So we did have some kind of simplification, but we really didn't have any drastic perfect zero denominator or zero remainder kind of problems. So this is not a perfect factor of this entire problem. Same thing here. This problem 2 and problem 1 are just the same types of problem, just rewritten differently. You'll notice this is dividing by x squared, y squared. We can, because x squared, y squared is a monomial, we can write it like this, and then do some simplification from the top to the bottom. So that's really what I did there. So if we go 3 minus 2, that just leaves me with 1. 2 and 2 make 0. Minus 3 minus 2, that's 1. And 3 minus 2, that's 1. And then finally here, we're going to put a minus there. 2 minus 2, or 4 minus 2 is 2. And 2 and 2 make 0. So this is your final answer here. You'll notice that there are no remainders, so this is one of the perfect factors of this entire problem here. You can reorder this too if you'd like, but the book doesn't reorder it for this this problem. So let's go and take a look at what long division looks like for these binomials. When we look at division, and instead of looking at it with this binomial here, we're going to look at just whole numbers. Long division is when you're wanting to see how many times does the number on the outside fit into the number on the inside. So how many times does 30 fit into 450? Well, 30 can fit into 45 once. 1 times 30 is 30. And then I subtract the two numbers. 5 minus 0 is 5, and 4 minus 3 is 1. Then, what we drop down, this is 0 right there. Now we ask ourselves, how many times does the 30 go into 150? And that is 5 times, because 5 times 0 is 0, and 5 times 3 is 15. Subtract this, and we get a remainder of 0. So 30 goes into 450 15 times. So 30 is a perfect factor for 50. But sometimes we're going to have a number like 2, and we're not going to know how many times it goes into another number like 137. So the first thing we ask is, how many times does 2 go into 1? Well, it doesn't. How many times does 2 go into 13? Well, it goes in there 6 times. 6 times 2 is 12. Subtract the 2. 13 minus 12 is 1. Drop down the 7. 2 goes into 17, not perfectly. 8 times 2 is 16. And subtract this makes 1. So we have a remainder of 1. Now, maybe in the past you have wrote down R1, but really this is 1/2, because there's 1 if we're trying to divide by 2. So 2 is not a perfect factor of 137. It's 68 1/2. So that right there tells me that 2 is not a perfect factor. And that's what we're really trying to do for these problems, is find out, is it a perfect factor? So if I look at this problem here, I want to see if x plus 4 is a perfect factor of x squared minus 8x minus 16. So I'm going to make my long division problem just like I did with my whole numbers. Now, can x plus 4 go into x squared? No, it can't, because this has 2 terms and this has 1. So can x plus 4 go into x squared minus 8x? Absolutely. So here's the big key though. We need to multiply something right here in this spot that is going to give my x plus 4 the same first term as x squared. So the question I ask myself, what times x plus 4 gives me an x squared in the beginning? And the answer is x. So x times x is x squared, and x times 4 is positive 4x. And now the important step here that most people fail to recognize all the way through is this turns into a subtraction problem. So the first term gets subtracted here, but then often forgotten is that the second term here is going to be subtracted as well. Most people neglect that because they only are focusing on the first term to subtract. So I'm going to draw a line there. These two simplify to 0, and then these make negative 12x minus 16. Now, in my next spot right here, I'm going to try to multiply just like I did with my 2 and my 30. I'm going to try to ask in this spot here, what number do I multiply by to get my x to look like negative 12? And to get my x look like negative 12, I'm going to have to multiply by, unsurprisingly, negative 12. So negative 12 times 4 is negative 12x, and negative 12 times x is negative 12x, and negative 12 times positive 4 is going to be negative 48, because negative times positive is negative. Alright, now we put these together. Now again, one of the common things that most people miss is that this becomes a subtraction problem. So what we have to do is subtract this whole second line, but that would make this positive, and that would make this positive. So be sure when subtracting that you're actually flipping both of those to its opposite symbols, not just the first one. We get so hung up on simpling out the first terms and feeling good about ourselves, we forget about this part, which is switching the 48. So our answer is 32. Now, again, if you put R32, that's not going to give us the right answer because that is kind of an elementary school way of doing long division. We're going to have to write plus 32 over our divisor, which is x plus 4. This is the correct answer. It's to show you that x plus 4 is not a perfect factor of this trinomial here, and you do have a remainder. Okay, now if I showed you over here, if I showed you a pretty easy problem where it's just x plus, like maybe just off to the side here, x squared minus 81 over x minus 9, you would see that this would factor completely to be x plus 9 in the numerator, because this is a difference of squares, x plus 9, x minus 9. Leaving me with just this in the numerator. So we know that this is a perfect factor, but I want to show it to you in long division form so you can kind of see it work itself out. Now, I'm just seeing how much does x minus 9 go into x squared minus 81. But watch when I write this here. I have to write this as x squared plus 0x minus 81. I have to leave a space there. And the reason why I have to leave the space is the same reason why if I go 508 divided by 21, I have to put the 0 in for the tens spot. I can't just put 58 instead of 508 because the 0 in the tens spot is a placeholder. Same with this problem here. The x that's missing has to be a placeholder when we do our long division, and that's going to be true when we go to the next section and talk about synthetic division. So we ask ourselves, does x minus 9 go into x squared? No, it doesn't. But x minus 9 does go into a binomial, x squared plus 0x. So again, I focus on what thing do I multiply my x by to make it look like x squared? And simply it's just x. X times x is x squared. x times negative 9 is just negative 9x. Now again, this is a subtraction problem, so I have to subtract and subtract, which swipes both signs right here, which is critical. If you don't actually do this, you'll get the problem wrong. So these simplify, and this becomes a positive 9x minus 81. So in this slot here, what do I have to multiply my x by to make it look like 9? And that is going to be a positive 9. 9 times x is going to be 9x. 9 times negative 9 is negative 81. And again, since this is a subtraction problem, we have to use our subtraction here and swipe here. And this will get this to simplify and this to simplify. So our problem, as you see it, our problem has no remainder, which means that the x minus 9 is a perfect factor of x squared minus 81, and it gives us an answer of x plus 9, which I showed to you over here before we started the problem. But what's nice about that is you can kind of see it in action. One more problem to end this short little first part of the video here. Let's go take a look at one more long division problem. See if we get a remainder. And maybe you want to try this on your own to see how far you can get. Pause the video, check your work, and then, come back and see what you did. Okay, so x minus 2 does not go into 3x squared, but it goes into this binomial. You need actually two spaces for a binomial there, and we'll look at that as we deal with trinomials next. So what times x is going to give me 3x squared? Well, that would be 3x. 3x times x is 3x squared. 3x times negative 2 is negative 6x squared. Now what's important here is that we change this to a subtraction problem. So we subtract this and swipe that. There we got some simplification, but then we have to get back to adding these up, which gives me 1x squared. And then this drops down, so minus 3x is our new part. So underneath here, what do I have to multiply my x by to make it look like x squared? Well, just an x. And let's see, did I make a oh, that should have been a cube from the very beginning. And instead of restarting the problem here, I'm going to just fix that and make that a squared. So sorry about that. So this fix is that the first term was a cube, and then I had to multiply by a square to make a cube. So I'm sorry I missed that. So this is going to be, see, I'm looking at the descending powers up here, and that was a good way to check my answer. X times x is x squared. X times negative 2 is negative 2x. Now we're going to carefully go up here, change the color. And that's going to be negative and positive. These simplify. And we're going to put those two together there. So negative 3 and positive 2 just gives me negative x. This drops down to negative 2. Now what do I, well, am I really close here? Let's go find out. What do I have to multiply my x to make it a negative x? Multiply by negative 1. 1 times negative x is negative x. 1 times negative 2 is, positive 2. Oh man, I was so close. Because when I do my subtraction, this becomes positive, this becomes negative. That simplifies. This does not. This gives me a negative 4. So that is going to be my remainder. That problem has a remainder, unfortunately. The remainder is plus negative 4 over x minus 2, which shows me that this is not a perfect factor of this polynomial. Also, this negative 4 there, you could have written it as minus positive 4 over x plus 2. Alright, that's the end of video 1. Part 2 is coming up next.